All right, lecture 32, transformations. So last time we were talking about parent functions, and we listed the 10 parent functions. So I'm going to list them now. All right, the first one is f of x equals c, where c is some real number. That's going to be the constant function. We also looked at the linear function. That's going to be f of x equals x. And then we looked at the quadratic function. The quadratic function is any function with the highest exponent of 2. So it's going to be x squared. That's the simplest way I can write that. All right. And then the fourth one we talked about was the cubic function. That is f of x equals x cubed. And then, of course, we can keep on going up by exponent, but we do want to move on to the 6 others. The next one that we talked about was the absolute value function. Absolute value is going to be absolute value of x. All right, so that's absolute value. And we also talked about the square root function, which is just the square root of x. And then from there, we went from square root to cube root. So this is going to be the cube root function. F of x equals the cube root of x. All right, then we talked about 3 more. All 3 of these have asymptotes, and I'll label that as we go along. We talked about the reciprocal function. The reciprocal function is f of x equals 1 over x. X cannot equal 0. So this has a vertical asymptote at x equals 0, but it's also going to have a horizontal asymptote at y equals 0. So 2 important things to know about the reciprocal function. That's where we start to see asymptotic behavior. All right, and the last 2 parent functions that we talked about were the exponential function, which is f of x equals a to the x power. A to the x power, where a is some constant, and a cannot equal 0. The exponential functions are always going to have horizontal asymptotes. Now, for this particular exponential function, the horizontal asymptote is going to be the x-axis, or y equals 0. But this could change into any number depending on what you have added onto the very ends. We'll talk about that a little bit today. So y could equal c for any real number. And then the last parent function that we talked about was the logarithmic function. The logarithmic function. And that is f of x equals log base b of x, where b has to be greater than 0. Now, this logarithmic function has a base b, and that b has to be a positive real number. That's why I have b is greater than 0. But it's also important to understand that logarithms are going to have vertical asymptotes. So these are going to have vertical asymptotes. And of course, with all vertical asymptotes, you write them as x equals some number c. So that's how you know it's going to be a vertical asymptote. You have x equals some number. But if we're talking about horizontal asymptotes, like back here, we usually have y is equal to some number, c. And that's going to be a horizontal line. So these are the 7 parent functions that we talked about. And we know that we can do some stuff to the parent functions to transform them into different functions. And that's mainly what we're going to be talking about today, is transformations. Okay, So there are three types of transformations. The first type of transformation is called a translation. A translation. Now, when you're dealing with any translation, you're really taking a function and you're moving it around. So translation could mean you move up, you could move down, and you could also move left, but you could also move right. So a translation is going to be any movement of a function, whether it's up, down, left, or right on the xy plane. The second type of transformation that we can talk about is a dilation. A dilation. So mainly when we're talking about dilations, we're talking about a function growing or shrinking. Or you'll hear me say stretch and shrink. So with a dilation, if you've ever gone to the eye doctor and they say, we need to dilate your pupils in your eyes, that means to dilate the pupils, make them bigger or make them smaller. So that's dilation. Now, with the dilation, like I said, it could either be a stretch or a shrink, depending on what number is in the transformation. So I'll leave it at that. Okay, so the third type of transformation is going to be the reflections. The reflections. So you can reflect a function over a line, and it could be any line, but we're going to focus on the x-axis and the y-axis today. So you could reflect something about the x-axis, or you could reflect something about the y-axis. And sometimes you can reflect something over y equals x if you're trying to find the inverse of a function. Okay, so those are the three types of transformations that you'll see. So there are three types of transformations we're going to be looking at today. All right, so on the next slide, what we're going to do is we're going to talk about translation. We'll look at an example of that. We'll also be looking at a dilation, what that means. And then on the third slide, we'll talk about reflections. Okay, so let's talk about translations. Now for a translation, you can move something up or down, right? So the first transformation is going to be f of x plus c. And what that means is you're moving up by c. So you can move a function up by adding a number to it. It's very simple. You'll see it in a minute. And then the other way you can go is down, and that would be if you subtract a number from f of x, like c. So this would be down c. Okay, so that's if you want to move something up or down. And then we need to talk about left and right and how that works. So let's talk about left and right. Now this time, we're not going to be adding a number to f of x. We're actually going to be adding a number inside the parentheses. So we're going to be adding something inside the parentheses. So you might see f of x plus c. And you might see f of x minus c. So you could add on the inside or subtract on the inside. Now, if you're adding on the inside, you're going to move left c. You're going to move left by c. And then if you're subtracting on the inside, that's going to be going to the right c. So that is up, down, left, and right. Now, some people are kind of, well, I don't know. they're kind of weirded out about the whole left thing. They think that, well, if you're adding on the inside, that must mean you're going to the right. Well, that's actually wrong. When you add on the inside, you're actually moving the entire function to the left. So if you add something on the inside, like let's say f of x plus 3, that means that this entire function is going to move to the left by 3. Same way as this. If I'm subtracting on the inside by 3, that means I'm moving to the right by 3. So a lot of kids get those confused. But do know that if you're adding, you're actually going to the left. And we can prove that by graphing. Okay, let's talk about dilations. Dilations. Okay, so when you're dilating something, you're either stretching the function or you're shrinking down the function. So let's say you have c times f of x, right? You're multiplying on the outside by this number c. Well, if c is greater than 0, greater than 1, that means that you're doing a vertical stretch. So that means you're doing a vertical stretch. You're doing a vertical stretch by a factor of c. So vertical stretch by a factor of c. So if I was to multiply on the outside by, let's say, 2, 2 is definitely greater than 1. So I would be taking that entire function and I would be vertically stretching it by a factor of 2. Another thing we need to talk about is shrinks. So if c is between 0 and 1, c is between 0 and 1, that means you're doing a vertical shrink. A vertical shrink by a factor of c. So that's if you're multiplying by something that's between 0 and 1. So if I was to multiply by 1/2, notice 1/2 is going to be between 0 and 1. So if you multiply a function by 1/2, what you're doing is you're shrinking that function vertically by a factor of 1/2. Another thing I want to say is we've been talking about vertical stretching and vertical shrinking, but we can also talk about horizontal stretching and horizontal shrinking. So what I want to start off by saying is a vertical stretch is if you have a number that's greater than 1 and you're multiplying on the outside. If c is equal to 1, then nothing happens. C is equal to 1, then nothing changes. But if a number is greater than 1 and you're multiplying on the outside by that, you're going to be vertically stretching. Now, a vertical stretch is actually the same thing as a horizontal shrink. So I'm going to write horizontal shrink in here, and I'm going to close that up. Likewise, if you're doing a vertical shrink, that's actually a horizontal stretch. So this is going to be a horizontal stretch. So that's the relationship between vertical stretching and horizontal shrinking. They're actually the same thing, at least if you're dealing with the XY plane. And a vertical shrink, so if you multiply by a number that's between 0 and 1, you're vertically shrinking, but at the same time, you're horizontally stretching because a vertical shrink and a horizontal stretch is the same exact thing. And I'll leave dilations at that. Okay, let's look at reflections. Reflections. All right, so we're going to be looking at two major ways that you can reflect. You could reflect something if you multiply on the outside by a negative number. So if I had negative f of x, then that is a reflection over the x-axis. So I'll say reflection about x-axis. So that means you're flipping something over the horizontal axis, also known as the x-axis. So you're basically just flipping it over. And then the other way you can reflect is if the negative is on the inside of the parentheses. So you could also have f of negative x. And what that means is you're reflecting about the y-axis. Reflection about the y-axis. Now, you've probably seen how reflections work in the past. You may have seen problems where they give you a shape, like let's say a square, and they tell you to reflect it over the x-axis. Well, what you'd be doing there is you would just be flipping it over the x-axis and it would look like this. Now, a reflection over the y-axis, that would just be taking the same box and flipping it over the y-axis. So then it would look like this. So I'm flipping it over the y-axis. Okay, so those are the three major types of transformations that you need to know about. And on the next slide, we'll do some questions from the problem sets. Let me see. We'll be doing the problem set for transformations. Okay. Okay, so your directions are for each function, name the parent function, and its transformation. Okay, let's start off with number one. F of x equals negative x squared. So for each function they give me, I want to name the parent function and the transformation. Since this has a highest exponent of 2, we know it's going to be a quadratic function. Quadratic function. And we also know that the parent function, p of x, is going to be just regular x squared. That's the simplest way I can write it. So now what about the transformation? What happens if I have a negative on the outside? That means I have a reflection. So you could write reflection about or over the x-axis. So what you'll see when you graph this with its parent function is that when you go to graph p of x, you'll get that U shape. So you'll have something like this. And then once you graph f of x, the negative x squared, that's going to flip over the x-axis and it's going to look like this. So that's number one. All right, number two, I've got g of x equals 3 times the square root of x. So this is the function that they give me. Well, I know that I have a square root, so this is going to be the square root function. The square root function. And I know that the simplest form of it is going to be p of x equals the square root of x. So I'm going for the most simplest form of what they give me in the problem, and that's called the parent function. Now, what's the transformation that's associated with this? Well, you're multiplying on the outside by a number c. And since this number is greater than 1, that means you have a vertical stretch. You have a vertical stretch by a factor of 3. By a factor of 3. Now, what you could also say about this function is, since it's a vertical stretch, I can also say it's a horizontal shrink. So if I didn't write this, then I would write this is a horizontal shrink by a factor of 3. So I could also say that, and I would be correct in both ways. So for each function they give us, we need to name the parent function and we need to name the transformation. Let's look at the next one. Number 3, we got h of x equals absolute value of x plus 5. Close that up with the absolute value symbols. And then I'm adding 4 on the outside. So I've got x plus 5 on the inside. I've got plus 4 on the outside. So what parent function is this going to be? This is the absolute value function. The absolute value function. And I know that I can write it as p of x equals absolute value of x. So what's going to happen here is you're actually going to be graphing a V shape. So if I was to graph this on Desmos, I would get something like this. I would get a V shape that goes through the origin. This is the x-axis, this is the y-axis. So I get that V shape, and then h of x is going to tell me what the transformation is. So what's going on here? Well, on the outside, I've got plus 4. So I'm adding 4 on the outside. That means I'm going up by 4. So we're going up by 4. And then what's happening on the inside? I've got a plus 5 on the inside. And if I'm adding, that means I'm moving to the left. So I'll say left by 5. So what is this going to look like? Well, I don't really have any tick marks on here, but you do know that I'm moving up 4, and you know that I'm moving left by 5. So it's going to look like this. And you're going to get a V shape kind of up here. So this is one of those translations where you're just moving the function around. You move the original function p of x to get h of x. All right, number 4 says f of x equals the cube root of x plus 1. So here, since it's a cube root, I know that it's got to be the cube root function. The way I write that is going to be p of x equals the cube root of x. So what's the difference between p of x and f of x? Well, we need to compare this function with this function. So what's so different about f of x? Well, I'm adding something on the inside. And if I'm adding on the inside, that means that I'm moving left. I'm moving left by just 1, since I'm just adding 1 on the inside. Now, if I had that on the outside, I would have cube root of x plus 1 on the outside. Then I would be moving up by 1. But since the plus 1 is on the inside of the radical symbol, that means that it's with the x. So I'm either moving left or right. Okay, let's look at 5. All right, so 5 says g of x equals x minus 1 squared. So x minus 1, the quantity squared, minus 3. So this one, the highest exponent is going to be 2. And I know that because if I was to expand this, I would have x minus 1 times x minus 1 minus 3. And if I was to multiply x minus 1 by itself, I would get x minus 1 times x minus 1. Now, using the FOIL method, I can multiply the first 2 terms to get x squared, the outer 2 terms to get negative 1x. The insides give me the same thing. And then if I multiply negative 1 by negative 1, I get positive 1. And then the last thing I do is I put the negative 3 on the outside. So now, simplifying this a little bit, I know I'm going to have x squared minus 2x plus 1 minus 3. And then the last thing I can do is I can put the regular numbers together. So I get x squared minus 2x minus 2. So this is a quadratic function because the highest exponent is 2. It's a quadratic function, so the parent function is going to be p of x equals x squared. That's the simplest form of a quadratic function, just x squared. And then to look at the transformation, you really can't rely on what we just found. This is in standard form. This is in standard form. But up here, this is in vertex form. Vertex form and standard form. You can kind of see the difference. When we want to do transformations, we want to look at the vertex form first. So we can write this in vertex form or standard form, but to look at the transformations, you got to actually look at the vertex form. So what's going on here? Well, this minus 3 on the outside is telling me to go down by 3. So we're subtracting 3 on the inside. I mean the outside. And if you're subtracting on the outside, that means you're going down. But then I'm also subtracting on the inside. That minus 1 on the inside is going to tell me to go to the right. So I'm going right by 1 point. So that's number 5. It's really hard to tell from the standard form what actually is going on with the function. So when you're doing transformations, it's much easier to look at the vertex form, but you can go back and forth between both. All right. We're going to look at 6 and 7 on the next slide. Okay, so 6 is h of x equals x plus 6. Number 7 is going to be f of x equals 2 to the x minus 4 power. And then number 8 is g of x equals negative log base 10 of x plus 5. Okay, so we're going to start off by identifying parent functions. This is the linear function. I can tell it's linear because when I graph it, I get a line. My linear function is p of x equals x. That's the simplest form of a line. And I see that I'm adding 6 on the outside. So I'm going to be going up by 6. And what you'll see when you graph this is 6 is going to be the y-intercept. 6 is going to be the y-intercept. So you know you're crossing the y-axis at 6. You used to cross the y-axis at 0 right here, but since you're moving up 6, you're crossing the y-axis at 6 now. All right, number 7. Number 7 is the exponential function. The exponential function. You can tell because you have a number a. So p of x equals a, and you're raising it to the x power. So that's the exponential function. So what transformation is going on here? Well, I know that my base is going to be 2. This is what's known as the base. And then what's going on up here is you're subtracting 4 with the x. Well, if you're subtracting with the x, then that means you're going to the right. You're going to the right by 4. The base isn't really going to play a part when we look at the transformations. But do know that 2 is going to be the base. And for number 8, our base is 10. Our base is 10. That's really not going to make much of a difference when we get to transformations, but this is the logarithmic function. You can tell because it says log. The logarithmic function. The simplest form of that is p of x equals log base b of x. Here our base is 10, so we put a 10 below the log. So what's going on here? Well, in terms of transformations, we have a negative out front. That means we're reflecting this over the x-axis. But also, I want to call your attention to this. We're adding 5 on the inside. So if we're adding on the inside, that means we're going to the left. We're going to the left by 5. So that's number 8. Those are the only 2 transformations that are going on. The base, like I said before, doesn't really factor much into, the decision about the transformation. Okay. On the next slide, we'll do 9 and 10, and then I'll wrap it up. All right, so number 9 is h of x equals 10 minus x cubed. 10 minus x cubed. And number 10 is f of x equals negative 1/3 times x plus 2 squared plus 7. Now, number 9 is h of x, and the highest exponent for this is going to be the 3. So this is a cubic function. A cubic function. So the simplest form of the cubic function is going to be x cubed. That's it. So what's the transformations that are happening? Well, you've got this 10 on the outside, but also you've got this negative right here. So what two things are actually going on? Well, since this 10 is on the outside and the 10 is positive, that means that you're going up by 10. So you're going up by 10. And then that negative on the outside, that negative is on the x cubed, so that means there's also a reflection going on. So you're reflecting over the x-axis. So that's number 9. Number 10, there's a whole lot of stuff going on, but since the highest exponent is 2, that's going to be the quadratic function. The simplest form of the quadratic function is p of x equals x squared, where p just stands for parent. So the parent function is x squared. So what's going on with the transformations? Well, we got this negative. We also have a 1/3. That's going to be some kind of dilation. We have a plus 2 on the inside, but we also have a plus 7 on the outside. All right, so going in order from left to right, the negative is going to be a reflection. So we're going to be reflecting over the x-axis. So that's what the negative means. And then we have a 1/3. So that 1/3 is going to cause some kind of dilation. Since 1/3 is going to stretch it horizontally, we could also say that this is a vertical shrink. So this is going to be a vertical shrink by a factor of 1/3. By a factor of 1/3. Now, another way to think about it is a vertical shrink is the same thing as a horizontal stretch. So you could also say it's a horizontal stretch by a factor of 1/3. So what else is going on with this function? Well, there's this plus 2 on the inside. That plus 2 on the inside tells me to go to the left by 2. And then the plus 7 on the outside is telling me to go up by 7. So that's what you'll be doing for your classwork today. You'll be identifying the parent function by name and by formula, just like I did right here and right here. And then you need to tell me what the transformation is from p of x to f or g or h or whatever